PostgreSQL uses the client-server model, where the client and the server processes are usually on different hosts. The communication between the client and the server is normally done via TCP/IP protocols or via Linux sockets. On the front end, we could have client application such as a Java program, command line tools, or graphical interface programs. These front-end clients will send SQL requests to the database server. Out of the box, Postgres provides PSQL as a front-end client. The server process manages database files, accepts connection from the client applications, and performs action on behalf of the client. The main process on the server, called the daemon process, has quite a few responsibilities. For instance, initializing shared data structures and memory space, kicking off utility processes such as the backend writer, the checkpointer, auto vacuum launcher, the log writer, stats collector process, and so on. Furthermore, the daemon process also listens for connection requests and then spawn a new server process for each client. It's obvious that the daemon itself is a mandatory process that should be running all the time in order for a user to connect to the database. Let's focus on the user connection request scenario. When the daemon process receives a connection request, it forks a new backend process. On successful authentication, the backend process will start handling requests from the client. Similarly, the process is repeated for all connection requests unless we hit the settings for maximum connections, in which case we get an error. Once a user is connected to the database, the user can normally read and write data using operations such as select, update, delete, and so on.